One, two, three. Hello everyone, it's June 10th. Alright, morning session. Let's get it going. Nothing of concern here. We have I was going to say calculator, no, it's calendar. My calendar 1. Implement a class called my calendar to store events. A new event can be added if adding the event will not cause a double booking. Your class will have the method book start end. Formally, this represents a booking on the half-open interval start to end, the range of real numbers x such that blah and blah. Okay, but start and end are integers. A double booking happens when two events have some non-empty intersections. There's some time that is common to both events. For each call to the method, myCalendar.book return true if the event can be added to the calendar successfully without causing a double booking, otherwise return false, and do not add the event. Your class will be called like this. We create the calendar and we call .book. So only one method, .book. Returns true, returns false, returns true. Yeah. Alright, doesn't seem to be very difficult. 1,000 calls. And the start and end are 0 to, okay. So basically, we just need to detect. We need to detect overlap. Right? That's the thing, detecting overlap. Actually, it is not simple. I think we can use segment tree for this, but it can take some effort to write segment tree. Any other methods? So we have a start and end, right? We have a range, and we give another range. How do we detect that the two range overlaps? Well, if we overlap, some ending is smaller than some beginning, right? That's when overlap happens, which means if we put all the endings together in a sorted way, right? And we say all the endings in there do not overlap. And then we have a new one come in. Yeah, if they do not overlap, then it shall match, right? It shall, like, if we put all the beginning in a sorted array and all the endings in a sorted array, then it should be a 1-to-1 match. But the problem is if you sort, you have to sort every single time, because if I had a new one added, right? If you have a new one added, you have to sort it again. Okay, so we can sort every time a new one push in. We sort it, and then the new start time. The new start time coming in, and we look for the, hold up. We have a range, and then we have another range to put in, and then the new start time is end time, start time. How do we know if it's inside a range? Well, we can sort the end time, right? End time we sort, and then we have a new start time, so we can binary search to find where the start time can. Well, where is the end time that is the smallest end time that is bigger than the start time, and then we check. So that is the, yeah, that is the end. That's the one we need to check to see if that range's start time, if that range's start time is larger than the current one, then we have an overlap. Otherwise, we need to also check the end time. So the end time of the current need to go through the exact same thing. But then the problem is just like if we can insert it, right? If we have something that we can insert, how do we maintain the order? Right, we cannot maintain the order. I mean, the number of calls at most is 1,000, so it's not going to be problematic. Let me think about the let's try the segment tree. I forgot how the segment tree works. I think segment tree. We have a segment. Let me look it up. I don't think this is cheating. I'm just gonna look up segment tree. Segment tree. All right, let's see. Segment tree. Competitive programming. Oh, that's so long. It allows answering range queries over an array effectively while still being flexible enough to allow modifying the array. Find the sum of consecutive array elements, or find the minimum element in such a range, O log n time. Thus, modifying the array by replacing one element, or even change the elements of a whole. Structure. Oh no, the segment tree will give you the sum. 0 to 4, the sum, the 0 to 2, give the sum. Okay, so now if I want to ask, what does this one solve? Only requires a linear number of vertices. First level of the tree contains a single node, the second contains 2 nodes. Okay, and it's worth noting that whenever n is not a power of 2, not all levels will be filled. The height is O log n, so we traverse O log n. So what does this one do? This one will answer the sum queries. I see 2 integers L and R, and we have to compute the sum of L to R in log n time. Like, can you just build a? That could be a prefix sum. Sum 2 to 4, 2, 3, 2 to 4 will give us -1. So 2 to 4. So we're gonna go here, right? Here, 2 to 2. That's this, and 2 to 4, 3 to 4. So these two added together. Okay. But we can update a query, modify a specific element. A2 equals 3, so this is init, so I update this. This is init, update this, this is init, update this. So we don't have to change the others. Okay, does this help us? I don't think so. What we want is a range, right? What we want is a range. Range as keys. How do you do range? It's an interesting question. No, I don't think it's a segment tree. Start and end. 10 to the 9th, right? Start and end. I mean, the worst, we can just go through every range, right? We go through every range to see if there's an overlap. I mean, a test case is only 1,000, right? Which means there are only 1,000 calls, so at most 1,000 things inside. So every time we got a new one, we just loop through everything and to check. I feel like there gotta be an easier way. I can write a simple solution. I think it might pass, but I want to keep thinking. I mean, simple solution will pass. That's why it's 1, right? You can expect we can make this say at most like 10,000. Then the simple solution won't work. Right? The O is like what, ON, right? ON solution. Now ON squared, right? It's ON squared. A naive ON squared solution. But for our current purpose, let's just get it done. And then we think about how we can improve on it. So to do this, we need self dot